G'day guys, how's it going? So in this video, we're going to start looking at something called methods in Rust. And essentially a method, in short, is a function that's associated to a struct. Now, I'll explain a little bit more as we go along, but let's just look at a solution to a particular problem based on what we know so far, right? So if I was to say to you, come up with a function that basically takes in a player and increases the salary, right? So we're going to pay them some money, right? How would you go about that currently? Well, you'd probably do something like this, right? You would say, okay, I need a function. I'm going to call it pay. I need to update the player. So then I would go, okay, there's a player. I need to make it mutable because I need to update that struct. So I'm going to go at mute player. And then basically I don't need to return anything. So then you would do this, and then you would do something as simple as, let's say, player.salary is equal to, and then you would include after this an amount. Let's say, well, in this case, it has to be an F64. And you would go plus equals amount, right? And then down here, let's say the scenario is to pay the player. In this case, we have to use at mute player 1, and I'm going to pay them $100, right? So I'd do something like this, and then maybe just to prove that it works, I would take this print here, and I'd say is now player 1.salary, right? Now what's going on here? I forgot to mark the original struct as mutable. But essentially this is what you would do, right? And this would solve the problem. Now if I run this, you can see the salary 1 minute is 0, then the next it's $100. Cool? Now if I also asked you, okay, on that same player, I now want to have a function that gets the first name and last name separated by a space. Well, then once again, you would come up and go, okay, I'm going to create a function and say, call it get player full name, or I will just say full name, right? We'll just call it full name. And then once again, you would take in a player. This time you're just reading it. So we go at player, and this would return a string. And then you might do something like, okay, I'm going to return a format. And you would say something like this. And then you go at player dot first name. And then let's say at player dot last name. And you save that. And what's going on here? Implicit returns. Sorry, what did I do here? Not sure why that's complaining. Why is this complaining? Mismatch, expected that, found, blah. This does return a string, right? Oh, sorry. I got a semicolon on the end. That's what it is. There we go. All right, so then let's say just after first name and last name, I come down here, and then I go print line, player 1, full name, oops, is, and then we call full name player 1. And I have to pass it in as a reference. Cool. Now if I save that and I run this, well, now we can see we're going to get full name is Daryl Duck, right? So that's my first name, my last name there, right? Cool. So that is the normal approach we know so far to handle the two requirements I just specified, right? However, if we think about it, these two functions are really just associated with the struct itself, which is the player, right? Now, we could do it this way, and we could continue to use our code in this manner, and it would work. There's not an issue. But how we like to think of things sometimes is as objects in the real world. So, say for the example we've got here so far, this struct player is really something that we could model in the real world, right? We could have a player in sports or whatever. So that's what I've done here, right? I've got a player, and this player in this case it's a video game player, right? Because they have a username. So this would model a video game player who has a username, and as a result, they have a first name, last name. And let's say they're an esports person, so they have a salary, and then we have a flag to say that they're active, right? So this represents an actual esports player. Let's say that, okay? Now, an esports player is always going to do the same kinds of things. You're always going to want to get their full name, and you're always going to want to pay them money at some point, okay? So generally, wouldn't it be nice if we could do something like this, right? So instead of calling full name, I could go something as simple as, and I'm just going to break the code here for a second, player one dot full name, like that. And in this case, we would say player one dot pay. Right? And we don't even have to worry about the at mute or anything like that. We just pay them $100. This is much cleaner code, right? This is the type of code that we want. Now, at the moment, this won't work, right? Because these functions that we're calling on the player are not necessarily specific to the player, right? They're not linked. These are not what we call methods. These are just regular functions where we have to pass in an argument, which is a type player. So how we do this in Rust, how we associate this function, right, this method to a player struct is to implement something called an implementation, which starts with impl and then the same name as the struct, right? Now inside here, we can now take this function, or these two functions, cut them out, and put them inside this implementation. Now, it still doesn't work down here. We can still see we're not getting the right thing. And that is because in Rust, what we want to do is instead of using the word player, right, we'll change this to say self, right? And self is a special word that's associated with this implementation that links to the struct with the same name as the implementation. So in this case, because we're using implementation player, this self is now linked to an object which is a type of player, right? So if this was called, say, user, then this would no longer work, right? In fact, it will even complain and tell us that it's not found in the scope, right? So this must match the same as this above. So that's why that will go away, right? So this is a special way of saying call to myself. Previously, when I was saying player, it was saying, no, you need to pass in the player, a player, right? But that doesn't work with implementations. We need to say this special keyword self, right? So if I change this for both of these, like so, if I scroll down, well, full name is still not working. Why is that? Let me go back. Okay, it's defined in an implementation. Okay. Interesting. This should work. What have I done wrong here? Hang on just one moment. So function full name, player. Maybe I need to use the actual word self here. So self is a special word that's also associated. I didn't realize I had to change it to self like that, but now I probably do actually. Yeah, the problem's gone away. So the one bit I was missing is that the parameter must be called self and is a type of self with an address, right? So we're just accessing the address of the instance of the object, which is this here, okay? I thought it could be called anything. It has to be called self. That's the bit I forgot. Cool. So this gives us the same behavior, right? So if I run this, we're going to get exactly the same result as we did before. But now we're able to use it with this dot notation, right? So we can go struct type dot method name, struct type dot method name. So the power to this is that I can now come in and say I want a player 2, right? And I can change this to username player 2. And I can also go player 2.pay and give them a different amount, right? Maybe player 2 played a little better than player 1. Sorry, that's a float. And I can say player 2's salary is, and all I have to do is go player 2 the salary, right? So this is beautiful. This is a lot cleaner, right? That we can do something like this. So we'll just quickly run it to prove that it still works. And we can say player 2 salary is 200, right? Because we paid them. Cool. Now, this self idea here, the fact that it says self at self is a little redundant, right? Rust sees it as a little redundant. So what you can do to shorthand this behavior is to just go at lowercase self, and you don't even need to specify the type. Same here, right? I can go at mute self and not need to specify the word self because once again, it's redundant. So this will still work, right? So if I run this again, run, and there you go, get the same result. Cool. So that is how we can implement a method on a struct and call it within our program. So that's it for this video, and I'll see you all next time.